Hello dear students, welcome back. This 2 marks question is from GATE 2017 exam. They have given you this program. You need to find the output of this program. So let us start executing it. Execution will always begin from the first line of main function, that is from here. So in this line, you are declaring a character pointer that is named x. Similarly, in this line, you are declaring a character pointer that is named I. Suppose these are those two pointers. They are of type char star. That means x will contain address of some character. Y will also contain address of some character. These pointers, they are initialized with these values. Now this is a string, this is also a string. That means whatever is the first character in the string, x will be pointing to that character. Okay. Suppose this is string, it is declared in read-only section. X is pointing to first character, that means A. Okay. So X is pointing here like this. Y is pointing to the first character of second string like this. Suppose address of this A is say 7. So X contains 7. If this address is say 77, then Y contains 77. Okay. In next line, we are calling this function and we are passing X and Y. So what is X? X is this address which is 7. What is Y? Y is 77. Now we are passing these addresses. That means in this function, these variables, they must be pointers because we are passing addresses. Okay, and you can see these are pointers only. So whenever this function is called, this S and T will be declared. Suppose this is S and this is T. You can see their type is character pointer. Hence they can point to characters only. And the addresses that we are passing, they are addresses of characters. So S gets 7. T gets 77. That means S is also pointing to this first string and T is also pointing to the second string just like Y. Okay. Now we are declaring unsigned integer that is initialized with value 0. In next line, we are declaring one more integer that is initialized with this value. Now what is this? This is ternary operator. So this expression will have this value if this is true, and this entire expression will have this value if this is false. Now we need to determine, is this true or false? Whatever is written before this question mark. Okay. So before this question mark, the condition that you have written is string length S minus string length T is greater than C. String length S is 3. This string has length 3. So string length is going to return you 3. This will return 5. So what you have written in this expression is 3 minus 5 is greater than C, which is 0, question mark, colon. This is string length S. What is string length of S? That is 3. And this is string length T, that is 5. Now if you think that this is false and hence value of this expression is 5, you are wrong. See, in question, they have specifically mentioned this line that string length returns a value of type size t and size t is unsigned integer. That means whatever is returned by this function call is an unsigned integer. So 3 is an unsigned integer. 5 is also an unsigned integer. Unsigned integer minus an unsigned integer will be an unsigned integer only. Okay. So whatever is the value of this bracket, that means whatever is this value, it is an unsigned integer. So this value cannot be minus 2. Minus 2 is negative. Whatever you get, it cannot be a signed number. Okay. So what will be answer of this calculation? Is it plus 2? No. See, for explaining this, you need to know the concept of underflow and overflow. Look. So let me just write here. See, this is the range of unsigned integers. That means you can think that number line starts from here. This is the smallest number that you can represent. And you can also assume that the number line ends here. So we are currently working with a finite number line. You cannot go beyond this point. So if you want to subtract these two numbers, that means if from 3 you want to subtract 5, normally what you will do, you are at 3, you want to subtract 5. That means from this point, go 5 steps back. So 1, 2, 3, 4, 5. This is -1, this is -2. Normally you will get -2. But in this number line, you don't have anything like -2. So from here, you want to go 5 steps back. What are you going to do? 1, 2, 3, 4, 5. See, the biggest number that you can represent in unsigned integers is 2 raised to the power 32 minus 1. Number previous to this number will be 2 raised to the power 32 minus 2. So here you have 2 raised to the power 32 minus 2. Okay. 3 minus 5 will be this number. Once you want to shift beyond this point, then there will be a wraparound of numbers and you will get the biggest number. See, 2 raised to the power 32 will be a very big number. Probably it will be of 10 digits. Let me see. So 2 raised to the power 32. Yeah, it is of 10 digits. So I don't think so it is visible. But the number is 4294967296. 4294967296. That means the biggest number that you can represent is this one, 95. Okay. This is the biggest number that you can represent. And answer of this calculation is this number. That means 94. Okay. So you are comparing this number and 0. Obviously, this expression will result in true. Okay. So this is true. Hence, 3 will be the value of this entire expression and 3 is assigned to this variable that is named length. Okay. Or len, length. Printf len will result in 3. Okay. So the answer to this question is 3. One more point that I want to highlight is, now this number, whatever is its value, that one, this is unsigned. This one, 0, that means C, this is also unsigned. In case you declare C as a normal integer, that means if this one is not an unsigned number and this one is a signed number, in that case also everything will be similar only. Because if you want to compare unsigned number with a signed number, in that case, this will get upgraded. This C, if it is a normal integer, to compare both of these values, you will have to promote C to unsigned number only. Okay. What I'm trying to say, if this is signed, if you want to compare A and B, if one of them is unsigned number, other one will automatically be upgraded to unsigned only. Okay. Now one last point that I want to explain is, why are we getting this value? That means why is there a wraparound? Okay. For that, you need to know basics of digital logic and computer architecture and organization. I've already completed all the PYQs of those subjects. Anyways, I hope that you know the theory and I'm just explaining why there is a wraparound. So 3 minus 5 is -2. How is -2 represented in computers? It will be represented in 2's complement form, because to represent negative numbers, we use this form. That means -2 will start with a lot of ones. See, this is 2, 0, 0, 0, so on, 1, 0. So this is a 32-bit number. This is +2. If you want to represent -2, take its complement. So its complement, 2's complement will be 0, 1, and all of these bits, they are ones. Okay, so it is a 32-bit number. Now, whatever is their type, we don't care. If it is an integer or even if it is an unsigned integer, result will always be this number only. 3 minus 5 will always give you this thing only. Whether you are working with unsigned integers or even if you are working with signed integers, in both of the cases, this is the result. But now it is up to you, how are you treating this bit pattern? If you treat this pattern as a signed number, that means if you are working with integers, then this will be negative because first bit is 1, sign bit is 1, so this is negative and 2's complement of this entire thing. So if you take its 2's complement, you will get this back only. Okay. So if you are working with signed numbers or integers, then this bit pattern means minus 2. But if you are working with unsigned numbers, then there is no sign bit. So simply take its value. Its value will be this. Okay. See, first bit is 1. That means the bit for 2 raised to the power 31, it is high. Okay. So obviously this number is greater than 2 raised to the power 31 and it is a positive number. That means we are talking about this number. Okay. So while editing this video, I realized that this number is not visible. So it is 4294967294. The result of this calculation is this one. Assuming that unsigned integers are of 4 bytes or 32 bits. If unsigned integers are of 32 bits, in that case, this is the biggest number and this one is our answer. Okay. So to summarize it, I want to say it all depends on how you treat this bit pattern. For example, if you perform some random calculation and say its answer is minus 1. Minus 1 will be represented in 32 bits like this. Yeah, so it will be all ones. So these are 32 bits of ones. They represent minus 1. Now it is up to you how you treat this pattern. If you are working with signed numbers, in that case, this is minus 1. If you are working with unsigned numbers in 32 bits, in that case, this number is the biggest number possible. So minus 1 is this one. If you get minus 2 and in your number system, there is nothing like minus 2. That means if this is the range, then minus 2 will just be this same number. Okay. Minus 3, it will map here. Minus 4 will map here and so on. I think you are getting the pattern. Okay. Have a good day.